Huh? Okay, good morning, students. How are you guys? This morning we're looking at logarithmic differentiation. I know very well that we are taught log and you want two of us. Huh? You were taught log now, isn't it? Okay. And you know the laws of logarithms, two of us. Huh? The laws of logarithms, one of the laws is laws of logarithms. One of the laws is if we have log A, it means we can write it in this form. Log what? A plus log what? Log B. Two of us. Huh? Okay. Then, second log. If we have log A all over B, this is the same as log what? A minus log B. Amen? Amen. Okay, the third one says if we have log A raised to the power of n, this is the same as n log A. True or false? That is log for you. That is log. Amen? Okay, yeah. So far, so good. Now we want to look at differentiation in calculus. Is that clear? We want to look at what? Differentiation in calculus. So for the fact that we'll be using logarithms to differentiate a given function, instead of log here, instead of log, we write in. Is that clear? So as long as calculus is concerned, differentiation is concerned. So 1, instead of log, we are going to write in. A is equals to in what? A plus in B. Amen? Then 2, in A all over B. This is equals to what? In A minus in B. Amen? Then 3, in A raised to the power of n. This is the same thing as what? N is A. So take note of all these laws. So as long as differentiation is concerned, we'll be using these three laws. Amen? Amen. Okay. So can we proceed now from here, right? We can proceed, right? So as long as differentiation is concerned, our focus is how to use these laws. Are you following?
Yes, sir.
Okay, so let us fix idea with example. Assuming example, if y equals to in x, and you are asked to find dy all over dx, it is not difficult, and it can never be difficult. Listen before you copy. Is that clear?
Yes, sir.
Don't rush the copy. But listen. Anyway, you don't understand, you go back to it. Yeah. So now, how can we differentiate this function? You ask yourself. It's simple as ABC. We can use either substitution to differentiate it, or we differentiate it direct. Let's write solution. Our y is equals to in x. Amen?
Amen.
Yeah. Ordinarily, if you want it to be fast, just assume that what is there? X, right?
Yes, sir.
So it means if you differentiate x, what are you supposed to have? 1, right? Yeah, you are supposed to have 1, 2 of us. So for the fact that we have in x here, use that one to divide the x. So it means our dy all over the x is equal to 1 all over what? X. So whenever you differentiate in x, you are going to have what? 1 all over x. Black. Leave it now. Leave it. You see that I have series of markers here, 2 of us. Do you understand?
Yes, sir.
So now, anywhere, anytime, you are asked to differentiate in x, you are going to have what? 1 all over x. So put it at the back of your mind. It's very important. Is that clear?
Yes.
Do you understand?
Yes, sir.
Okay. So let me show you another method. You either use substitution that will lead to what is called product rule. Is that clear? But that one will take you time. Is that clear? So assuming we are to differentiate this, we want to use substitution. We'll now say, let any alphabet is equals to what? X. So let P equals to what? X. Amen? So this implies that. It means our y will now be equals to what? In P. True of us? True of us?
True.
Do you understand? In P, right? Okay. So now, what we need to do here is we have to differentiate this with respect to P and differentiate this function with respect to what? X. True or false? So let us differentiate this function with respect to X. It means our dp all over the x is going to give us what? 1. Because if we differentiate x, it's 1. True or false? 1. Then we differentiate this function with respect to p. So it means dy all over the p. If you differentiate in p, what is supposed to have? 1 all over what?
X.
Yeah. 1 all over p now is p that is there. 1 all over p. True or false? So now your dy all over the x, therefore your dy all over the x will now be equals to the product of this and this. It means dy all over the p times the p all over what? Yes. Are you seeing what I am saying?
No, sir.
You are not seeing. Look at the board now. You want to arrive at this answer again. Look at it here. So it implies that it means our dy all over the x is equal to dy all over the p is what? 1 all over p. True of us. So 1 all over p times the p all over the x is what? 1. Then what is your p? X. So you can now see that our dy all over the x is equal to 1 all over x. 1 times 1. Is it not the same thing as? So you can now see that it's the same answer you arrive at when you use substitution. You did not understand?
Yes, sir.
Huh?
Yes, sir.
Where?
Substitution.
Okay, it is the substitution that you are confused.
All of them.
Huh? It's the substitution that you are confused.
No. That's from the beginning.
Some of you, your minds are not here. That is not the truth. We came to class with series of problems. So you want to understand, your mindset is not here. Somewhere else. Yeah. That's just the truth. If not, this is simple explanation that I'm trying to do. I said if you are asked to differentiate in x, whenever you are differentiating in x, know that is 1 all over what? X. So it means your dy all over the x is 1 all over what? X. Two of us. Okay. How? I said, if I were you, if you have something of this form, note that this is what you have been given, just within you. Thank you. Within you, this is what you have been given. You understand? So if you differentiate y, what are you supposed to have? The other day I taught you how to differentiate now, two of us. Two of us. If you've forgotten how to differentiate, you people are not serious. You don't read, you don't study. But you are always on media with your phones. You don't read. Your reading is your phone. That is what you people are doing. So how can you know there's something? You people don't read. So let me define differentiation again. Ax raised to the power of what? Now, this is y equals to ax raised to the power what? So if we are to differentiate this function, this is a function. The other day I told you, this is what? A constant, two of us. And you not copy it. This is independent variable. This is power or index. This is dependent variable, two of us. So if we are to differentiate this function, it means our dy all over the x will now be equal to use this to multiply this. N times a, na or an, na, x, an or na, whichever one, then raised to the power of n minus 1. I told you the other day in our last class that if you want to know differential calculus, that is differentiation, you must have this offsets. This is the formula for what? Differentiation. That is why I said if you are asked to differentiate, if y is equals to 2x raised to the power of 5, and they ask you to find dy all over what? Dx. Do you need someone to tell you? No, with this formula, it means This formula is here. So anything you are doing here, you are going to apply this formula here. True or false? What is your A here? 2. What is your N here? 5. So it means our dy all over the x is equal to what we do? 10. So it means 10x raised to the power of what? 5 minus 1. Amen? Then it implies that our dy all over the x is equal to 10x raised to the power of what? 4. This is how to differentiate. The problem you people have is you don't study anymore. Your study room is your phone. Every now and then, if there is no lecturer, you press your phone. You are on WhatsApp or Facebook, TikTok, or anything. That is what people are doing. So how will you know and learn? There is no space. This is very bad. These days, this generation. It's very bad. So if now you have to differentiate this function, what do you think? What are you supposed to have? Do I have like that? Understand? If you have to differentiate y equals to x, if you have to differentiate x, what are you supposed to have? It's 1. Because here we now, our dy all over the x is equal to, we have invisible 1 here. So you need to multiply here, it's the same thing. So x raised to the power of 1 minus what? True or false? So your dy all over the x is equal to x raised to the power of 0. And anything raised to the power of 0 is what? 1. So you can now see that dy all over the x is equal to what? 1. True or false? So why are people confused? You don't study.